We are going to be having a look at the properties of 2D shapes. We are first going to look at quadrilaterals. So quadrilaterals are 2D shapes that have 4 straight sides and they have 4 angles. Right, now some other properties of quadrilaterals is that the sum of all the 4 angles, so the sum of all 4 angles is equal to, can you remember what it is equal to? It's equal to 360 degrees. Right, so let's have a look at an example. We are going to look at the square. Okay, and how I indicate that my square has all 4 equal sides is I'm just going to put one small little line on each of my sides, and that is to indicate that one of the properties of my square is that all 4 sides are equal. Right, so that is one of the properties of my square. In a square, we have got 1, 2, 3, 4 angles, and each of those angles are right angles. So we have got, so each angle is equal to 90 degrees, which is called a right angle. So 90 degrees is called a right angle, and all of our angles are also equal. Because each of the angles are equal to 90 degrees, all our angles are therefore equal. Now, because a square has 4 angles and each of those angles are equal to 90 degrees, let's have a look at the sum of all 4 angles in any quadrilateral being equal to 360 degrees. Let's prove that with our square. So 4 angles that are equal to 90 degrees, we can multiply 90 by 4, and 90 times 4 is indeed equal to 360. So the sum of the angles in our square is equal to 360 degrees, but that's not specific to a square, that's for any quadrilateral. So the sum of the angles, all the angles in any quadrilateral, is going to be equal to 360 degrees. So we can just prove that with our square. So if you ever forget what the sum of the angles in a quadrilateral is, you can draw a little square, remembering that each of these angles here are 90 degrees, or right angles, which is equal to 90 degrees. Then you can say 90 degrees times 4, or you can plus those 4 angles together and you will get an answer of 360 degrees. Right, so what we would like to see is some more properties of our square. So we've seen that all the sides are equal. We also would like to know about parallel lines. Okay, so parallel lines are lines that never meet. So the distance between those two lines stays the same. And we indicate parallel lines by those little arrows. So as you can see, this line here, or this side and this side, so our opposite sides there are parallel, and our opposite sides there are also parallel. So because this side here is not parallel to this side, we indicate that by putting 2 arrows on the sides that are equal or that are parallel to each other. Right, so we can say that opposite sides are parallel. So that's another property of our square. Right, so we've mentioned about our angles, so that's all fine. Now we want to have a look at something else called symmetry. How many lines of symmetry does our square have? Now a line of symmetry is a line, so let me draw one of these lines. Line of symmetry is a dot, so I'm going to do it as dotted lines, is a line on which you can fold that square in order to get a mirror image. So you can fold it perfectly, and then this side and this side will meet up perfectly. So we've got one line of symmetry there, we've got another line of symmetry there, a diagonal one, and another one there, and another one there. So with our square, we have got 4 lines of symmetry. Right, so the properties of our square, all 4 sides are equal. Each angle is equal to 90 degrees, and therefore all our angles are equal to each other. Opposite sides are parallel, and we have got 4 lines of symmetry. Let's have a look at our rectangle. Right, let's try and neaten that up a bit. Right, so our rectangle has 1, 2, 3, 4 sides, which obviously makes it a quadrilateral. We have got opposite sides are equal. So we indicate that by putting one line on 2 of those opposite sides that are equal and 2 lines on the other 2. So that's one of our properties. Opposite sides are equal. Right, let's have a look at another one of our properties. Just like the square, we have got right angles for all the angles in our rectangle. Okay, so all angles are equal, and each of those, so each angle is equal to 90 degrees or a right angle. Right, so that is important for us to know. Opposite sides are equal, and all 4 angles are equal, and each of those angles is equal to 90 degrees. Right, let's have a look at some other parts of our rectangle, or properties of our rectangle. Let's have a look at parallel lines. Remember, our parallel lines are lines that never meet each other. The distance between them will never change. So those are 2 straight lines. So we've got here opposite sides are parallel because the distance between them will never change. Right, so that's another one of our properties. Opposite sides are parallel. Right. Now let's have a look at our lines of symmetry. Okay, so with our rectangle, because not all 4 sides are equal, we won't have 4 lines of symmetry because we won't be able to do diagonals. Our diagonals will not be lines of symmetry because this line here and this line here will not match up perfectly if we were to divide along a diagonal. So we've only got 2 lines of symmetry, a horizontal line there and our vertical line there in the middle. So in our rectangle we have got 2 lines of symmetry. Right, and these are the properties of your rectangle. Right, we are going to be having a look at a rhombus. A rhombus is a bit like a skew square. So let's just try and neaten that up a bit. Right, so our skew square or our slanted square is called a rhombus. So again, just like with our square, all the sides are equal. So that is one of the properties of our rhombus. All four sides are equal. Okay, and just like with our square again, opposite sides are parallel. So opposite sides are parallel. And that is another property of our rhombus, is that opposite sides are parallel. Let's now have a look at our angles. With a rhombus, not all your angles are equal, and we don't have any right angles in a rhombus, but opposite angles are equal. Right, so these two angles here are called obtuse angles because they are greater than 90 degrees. They are greater than a right angle. And these angles here, these opposite angles, are called acute angles because they are less than 90 degrees. They are less than a right angle. So we end up with opposite angles are equal. Okay, and you can mention that two of those opposite angles are obtuse and two of those opposite angles are acute. Right, if we have a look at lines of symmetry, we will see that we only have diagonals as our lines of symmetry. So we go from angle to angle and we only have two lines of symmetry. Right, so these are your properties of your rhombus. Right, we are going to be having a look at a parallelogram. So our parallelogram looks a bit like a slanted rectangle. So just like with our rectangle, our opposite sides are equal. So that is one of the properties of our parallelogram. The opposite sides are equal. Right, then let's stay with our sides. And again, just like with our rectangle, in our parallelogram, the opposite sides are also parallel. So the distance between those sides will never change. So opposite sides are parallel. Right, so let's have a look at our angles. Our angles, just like our rhombus, opposite angles are equal. So two of those opposite angles are obtuse. So these two are obtuse. They are greater than 90 degrees, but less than 180. And these two angles are acute. So again, we can say opposite angles are equal. Right. Now let's have a look at our lines of symmetry. With our parallelogram, we will find that we have 0 or no lines of symmetry. So no matter where you try and draw a line of symmetry in your parallelogram, you will find that there is no line that we can draw that will create a mirror image on either side. So it's still a property of your parallelogram that there are no lines of symmetry in your parallelogram. Right, so these are all your properties, and there is your shape of a parallelogram. Right, we are going to be having a look at the trapezium. The trapezium does not have any equal sides, so we indicate that by putting a different number of lines on each of our sides, and that is obviously one of our properties. So none of the sides are equal. Right, then let's have a look at our angles. None of our angles are equal either, so we put a different number of these curved lines on each of our angles. So none of excuse me, the angles, none of the angles are equal either. Let's have a look at our lines of symmetry. We do not have any lines of symmetry, and that is mainly because none of the angles are equal and none of the sides are equal. So we won't be able to have any lines of symmetry. So no lines of symmetry. And then we do have, the one thing that we do have is parallel lines. So we've got the top side and the bottom side, which we call bases. So the top base and the bottom base are parallel to each other. So we have got one pair of parallel sides, and that those are your two bases. So these are the properties of your trapezium. We are going to be having a look at the kite now. So obviously you will be drawing a better kite than I am, because you will be using pen and ruler, or pencil and ruler, on your paper. So please excuse my drawing. So let's have a look at the properties of a kite. When we have two sides that are next to each other, sharing a common vertex. Now this point here is called a vertex. So two sides sharing a common vertex, or sharing a vertex, those two sides are called adjacent sides. Right, so I will use that word to refer to these sides that share a common vertex, and I'm going to say that the top two adjacent sides are equal, and the bottom two adjacent sides are also equal. Right, so obviously these sides at the top are not equal to these sides at the bottom, but these sides at the top are equal to each other, and then these sides at the bottom are equal to each other. That is why I've indicated them with more than one line at the bottom. Right, so that is one of our properties. So we have two pairs of equal sides. So there's your one pair is at the top, and there's your other pair at the bottom. Right, let's have a look at another property of our kite. If we have a look at those two angles, we will see that they are equal to each other, because they intersect at the same angle. So this line here intersects this side, or this side here intersects this side at the same angle that these two sides intersect or bisect. Right, so these two angles are equal. So we have one pair of equal angles, or one pair of angles. So let's rather say one pair of opposite angles are equal. Right, and that is because these two angles here are not equal to each other, and they are not necessarily equal to these angles on the side either. Right, let's have a look at lines of symmetry. We have only got one line of symmetry for our kite, which is right down the middle. So we have got one line of symmetry. Right, we do not have any parallel lines, so we can state that. We can say that there are no parallel lines, or none of the sides are parallel. You can also say that. But it's probably best if you are asked to give two properties of a kite, rather give one of these three or two of these three, instead of saying that there are no parallel lines. Right, so these are the properties of your kite. Right, now we move on to triangles. So a triangle is a three-sided shape, like what we've got on the side, and the sum of all the angles in a triangle is equal to 180 degrees. So the sum of all the angles in a triangle is equal to 180 degrees, and all triangles will have three sides and three angles. So that is for all triangles. Now, if you forget about the sum of the angles in a triangle, what you can do is draw any quadrilateral, and if you happen to remember that the sum of the angles in any quadrilateral is equal to 360, then you can draw a quadrilateral and divide that quadrilateral in half, and what you will see is one triangle there and two triangles there, or another triangle there. So you end up seeing that half of any quadrilateral is equal to two triangles. You will divide your quadrilateral up into two different triangles. They might even be the same if we're working with a square. So we've got two triangles. So the sum of the angles in any quadrilateral is 360. So if we divide any quadrilateral up into, we draw a diagonal somewhere, we will get two triangles, which means that in one triangle we need half of our 360 degrees, and in the other triangle we need another half. So half of 360 is 180. So the sum of the angles in each of these triangles has to add up to 180, so that you get a full sum of 360 for your entire quadrilateral. So that's just a little way to remember the sum of the angles in a triangle, if you do remember the sum of the angles in a quadrilateral. Right, so let's have a look at this triangle here. Let's consider equilateral triangles and their properties. So if we see this triangle, I will show you that those three sides are equal, even though they may not look equal. I will indicate to you that they are equal by drawing one of these little lines on each of my sides. So that indicates that that all the sides in this triangle, in this equilateral triangle, are equal. Hence the name. So we have, that's one of your properties. So all three sides are equal. Right, so that's your one property. If we have a look at our angles, all our angles are equal as well. So all three angles are equal. So again, hence the name equilateral triangle. Most things are equal in our equilateral triangle. If all three angles are equal in our equilateral triangle, we will therefore be able to find out what each of those angles is equal to. So because we know the sum of all three angles in that equilateral triangle, or in any equilateral triangle, is 180, or in any triangle, and we know that in an equilateral triangle all three sides are equal, we just need to divide our 180 by 3, and we end up with 60 degrees. Right, so 180 degrees divided by 3 is equal to 60. So that shows us that each angle in our equilateral triangle is equal to 60 degrees. Right, so let's have a look at our lines of symmetry. So because in any 2D shape, if we have got 3 equal sides and 3 equal angles, we will also end up with 3 lines of symmetry. So we end up with 1, 2, I'm actually just going to draw them as lines so that you can see them better, and 3. So we've got 3 lines of symmetry there. So let's write that as one of our properties, 3 lines of symmetry. Right. So again, I'm just going to repeat that. If your 2D shape has 3 equal sides and 3 equal angles, it will also have 3 lines of symmetry. So if you fold your triangle on either one of these lines of symmetry, you will get a mirror image. Right, so that takes us back to the square. Remember, our square has 4 equal sides and 4 equal angles, and it therefore had 4 lines of symmetry. And we'll see later on with some other polygons, regular polygons, that rule will still apply. Right, so these are your properties of the equilateral triangle. Right, let's have a look at the isosceles triangle. In an isosceles triangle, these 2 adjacent sides are equal. So there we've got one pair of adjacent sides are equal. Right, so one pair of adjacent sides is equal, and what we can use is we can even use these lines just to remind us that it's the base angles that are equal to each other. So that's just a little trick that you can use. So these lines obviously indicate that these lines here indicate that these sides are equal. And then you can use that to help you remember that these base angles are equal. So that's another property of our isosceles triangle, is that the two base angles are equal. Right. Now let's have a look at our lines of symmetry. We have only got one line of symmetry for our isosceles triangle, and that is directly down the middle. So one line of symmetry, and these are the properties of your isosceles triangle. Right, let's have a look at the scalene triangle. Our scalene triangle has no equal sides, so none of the sides are equal. So that is one of our properties. None of the sides are equal. Right, none of the angles are equal. None of the angles are equal. And it has no lines of symmetry. No lines of symmetry. Right, and these quite simply are the properties of your scalene triangle. Right, this triangle here is a right-angled triangle, and the only thing that makes a right-angled triangle is that it contains one right angle. So it contains one right angle. Okay, so now if these two angles here are equal to 45 each, then we would have an isosceles and a right angled triangle. So it would be called a right angled isosceles triangle because it would have a right angle and it would have your two base angles equal to each other, which would mean that these two sides would be equal to each other, and that would make it a right-angled isosceles triangle. But the only thing that makes a right-angled triangle is that it contains one right angle. Right. Remember that a right angle is 90 degrees. Let's have a look at this triangle here. This triangle is called an obtuse triangle, or an obtuse angled triangle. And the only thing that makes an obtuse triangle or an obtuse angled triangle an obtuse angled triangle is that it contains one obtuse angle. Right, so remember, an obtuse angle is an angle that is greater than 90 degrees. So it is 90 degrees or greater. Right, so let's have a look at our triangle over here. This is called an acute angled triangle, and that is because it contains, so it's an acute angled triangle or an acute triangle, and that is because all angles are acute. Right, so we've got our right angled triangle contains one right angle. Our obtuse triangle, or our obtuse angled triangle, contains one obtuse angle, which is 90 degrees. Let me just write here, or greater, or let me actually just write here, greater than 90 and less than 180. So greater than 90, this angle here, and less than 180, because that is what an obtuse angle is. Right, and then we've got our acute angled triangle, in which all the angles are acute. Right, if we have a look at our equilateral triangle, we have got 3 equal sides and 3 equal angles. We will therefore have 3 lines of symmetry. Okay, let's have a look at our square. If we have 4 equal sides and 4 equal angles, we will have 4 lines of symmetry. Right, now let's have a look here at this shape, which has 1, 2, 3, 4, 5, 6, 7, 8 equal sides. So these sides are meant to be equal. So if it was drawn to scale, or if it was drawn more accurately rather, these sides would all be equal. So we've got 8 equal sides. So this is called a regular octagon. So I call it a regular octagon because regular polygons, and a polygon is a shape with 3 or more straight sides. A regular polygon has equal sides. So it has 3 or more equal sides. So an equilateral triangle is a regular polygon because it has 3 equal sides, but a scalene triangle is an irregular polygon because it has 3 sides, but they are not all equal to each other. All right, so a square is a regular polygon, but because it has 4 equal sides and 4 equal angles. But a trapezium is an irregular polygon because it has 4 sides, yes, 4 straight sides, but they are not all equal. Right, so a regular octagon has 8 equal sides and 1, 2, 3, 4, 5, 6, 7, 8 equal angles. And it will therefore have 8 lines of symmetry. So we go from corner to corner, or from angle to angle rather. So that there's 4, and then we go from side to side. Right, so again, if this was drawn more accurately, you would be able to see your lines of symmetry more accurately as well. Let's have a look at this shape here, which has 1, 2, 3, 4, 5, 6 equal sides. So this is called a hexagon. A hexagon is a polygon that has 6 equal sides, 6 equal angles, or a regular polygon rather. And an irregular hexagon would have 6 irregular sides, so 6 sides that are not all equal. Right, so because our hexagon has 6 equal sides and 1, 2, 3, 4, 5, 6 equal angles, it will also have 6 lines of symmetry. So we go from angle to angle and side to side, and we end up with 6 lines of symmetry. So as you can see, when we are working with, let's write it out, regular polygons, when you're working with regular polygons, the number of equal sides and equal angles is equal to how many lines of symmetry you will have for that polygon.